Okay, you plug through the math, you get a negative here, and the question is, what does this negative actually mean? This formula is based upon the force on 1 is based in reference to where 2 is. Because if Q1 were down here, that force would be upwards. If Q1 were over here, it'd be to the left. So we need to somehow give a reference, give some indication of what that negative actually means. And that negative actually means that it's going towards R2.
Okay, so
I left a R2 hat out.
so you wouldn't, on top of that, negative 21.1 newtons, write another negative on
No,
that?
no. That is a rookie mistake. Other questions? Because I'm gonna give you a problem that way too many people miss on the test. All right, this is a problem that way too many people miss on the test, and it made me sad. Alright, so 5 microcoulomb charge here, 8 centimeters away, I have a negative 3 microcoulomb charge. That's the same problem as we have over there. And then over here, 8 centimeters away, I have a 5 microcoulomb charge. I want to enter the force, the total force on electric force on, we'll call this Q1, Q2, and Q3. The total force, electric force on charge 2. Now we found the force, Newton's third law, if there's 21.1 newtons, if the magnitude of the force on this is 21.1 newtons, the magnitude of the force on that would be 21.1 newtons. Newton's third law, they have to be equal forces, opposite directions. Okay. So, what is the total force acting on that middle charge? And there are probably 3 answers that students would come up with if this were a test. I will say, Luis, you are correct. You agree? Erica? Anyone else? So we have 3 people who say the same thing. Doing physics by democracy. All right, so the back part of the class has basically been represented. What about the rest of it? The rest of the class? What's your gut tell you?
I feel like it's essentially just 2 of the same answer total, so.
41.2 or 42.2?
Negative 42.2 newtons R hat squared, R hat 2.
All right, so we have, the third answer that sometimes students come up with is the positive of that instead of negative.
Okay.
All right, the correct answer is
0.
And don't forget, I'm picky about those things, 0 newtons.
0 newtons.
All right. Now, here's where the trick comes in. If we did a straight plug and chug, then I know from this combination right here, so this is the force, electric force on 2 from 1, plus the electric force on 2 from 3. Okay. Basically, the total force is the sum of the forces. If you plugged in, you get negative 21.1 newtons plus negative 21.1 newtons is equal to negative 42, there's a mistake here, obviously, 22 newtons. This is one approach. The trouble with this is you've left off the direction piece of it. Because this is actually, this is the force on 2 from 1, so this is R1 hat. And here, this is R3 hat. They have two different reference frames. So when you are doing this, the two approaches are, one, you place strict adherence to the math. So now we need a way of combining R1 hat and R3 hat. I know that at this point right here, R1 hat is going this way, and R3 hat is going this way. Because the radial unit vector goes away from its center, so away from 1 is that way, away from 3 is this way. And so at this point, they are negatives of each other. And so I could write this as negative 21.1 newtons R1 hat minus 21.1 newtons negative R1 hat. The negatives cancel out, and you end up with 0. So method 1, strict adherence to the math. Please keep track of your reference frames. Method number 2, which is usually simpler, is, let's see, I know that it's being attracted because they're opposite charges, so I got 21.1 newtons going this way, and those are attracted, 21.1 newtons going that way. They'll cancel each other out. Answer is 0. So think through the directions, or place strict adherence to the math. Those are basically the two options. There will be times in which you're going, I don't know. In which case, you probably have to place strict adherence to the math. Or some students do, panic. Preferably not the best option. But that's just the way I'm rolling right now. Questions up to you? I know what you're thinking. Hey, all this is great, but can we make it look more complicated? Yeah, we can. Let's do it. We'll stick with the same numbers. So I got a 5 microcoulomb charge here, microcoulomb charge here. I got a negative 3. Wow, something's just wrong in my brain. Negative 3 microcoulomb charge there. I'm sure we'll make it 8 centimeters apart just because we've done the math already. And then I've got another one, 8 centimeters there, a 5 microcoulomb charge. And we'll call this Q1. Q2 and Q3. And I want to know what is the total electric force on 2. I know the magnitude of the forces here involved. Let's just think through the directions. And we'll go for that stunning visual effect as usual. What is the direction of the force on 2 from 1? Okay, I saw some fingers pointing in that direction. Generally, if you're pointing with a pencil, I'm not quite sure which way you're pointing. So you're going that way, you're going that way, so you two disagree. At least I'm not sure which way you were pointing.
I'm too scared to speak now.
I find that hard. Good, that way. All right, so you and Erica are going that way, Abby's going that way. All right, we got another vote for that direction, so we're now 2 and 2. Ooh, we're 3 and 3 now. 4 this way, 3 this way. I got yours, Jackie. Stephanie and Ryan, I don't think I have your votes yet. We got 5 going that way. Stephanie? So you're changing your mind?
Because if it's similar to that last question, with it canceling out, even though it's going down.
All right, what, the question is just dealing with those 2 right there, not dealing with that one at all.
Can you restate the
I'll
question?
stay where
I missed the question.
What is the direction of the force on 2, charge 2, from charge 1? So you're going that way, you pointed both directions, so
This way.
one of those is correct. All right, it is indeed that way. Because they are opposite signs, it is being attracted, so it is being pulled in that direction. So that's the thinking through it, of opposite signs attracted. What is the direction of the force onto from 3? Onto from 3. Is this pushing or pulling? All right, I'm seeing a number of fingers pointing downwards. It is indeed pulling.
Oh.
This is pulling.
Well,
Pulling
technically
down.
pushing down.
Yeah.
So either.
Pull,
Really?
yeah. Pulling,
Yanking.
cause they're
Push-
attracting.
I'm getting into semantics argument. The force is downwards, whatever verb you want to throw in there. I don't think you can, if you're below it, I don't think you push down, but that's just,
Divine intervention.
that's a generational thing, I guess. All right, so we have, I know the magnitude is 21.1 newtons because we have done this. 21 newtons. But the question is, what is the total force? And I just can't write, I got 21.1 and 21.1. I need something else in order to flesh that out. How do I express the total force?
Can we do I hat, J hat?
Okay, which way do you want to make what?
I want positive I hat to go that way and positive J hat to go.
So I hat, J hat. And so our answer would be negative 21.1 newtons I hat minus 21.1 newtons J hat. Done. If you really, for some reason, you know, the usual childhood scars, really don't like rectangular notation, let's just do a quick review of the trig and put it into, well, actually, we don't need to use trig here. We can also think through it. But if you want to make it more complicated, go for it. The total force is, I'm going 21.1 newtons this way, plus 21.1 newtons that way. My resultant that is my sum. I can put this in polar form if I know the magnitude and the direction. Well, in this case, I know that's a 45-degree angle. How do I find the magnitude? I think Stephanie is sort of whispering it.
Pythagorean theorem?
Yes. And so this will end up being whatever 21.1 square root of 2 is. That's the magnitude. Someone just tap that out quickly, I appreciate it.
Oh, you want more? Newton, sorry.
And then the direction, well, 0 degrees is this way. 90, 180, an additional 45, so 225 degrees. So for the polar form enthusiasts, and for those who have childhood scars about this, I'm sorry. times my parents yelled at me for getting the wrong form. I said polar form. I'm sorry. In retrospect, I would actually be shocked if my parents actually knew what rectangular or polar form were. I'm thinking of mom might have done. Dad moved on. Anyway. My dad was. All right, let's make it more complicated. I want to know what is the force, the electric force on, total electric force on one. I've asked questions similar to this on tests, quizzes, and so forth, and it's made me sad way too often. You can pretty much expect on the first test that there's going to be some question where you're trying to find a force on an object where you've got to do something more than just adding two numbers together. All right. Let's sort of do a rectangular form here, so we'll just stick to the same convention. So the total electric force on one would be the total electric force on one from two, plus the total electric force on one from three. It's nothing earth shattering, just total electric force on one is the sum of the forces from the other, caused by the other object. I know this one already because we've done that one. I know it is pulling, they're opposite signs, so it is pulling over there. So this is going to be 21.1 newtons I hat. That's that. Now I figure this out. So I have two charges here. 5 microcoulombs, 5 microcoulombs. First off, in which direction will the force be applied? This is charge 1, charge 3. In which direction will the force on 1 from 3 be? Okay?
Yeah.
So that is the force on 1 from 3. They are same sign, so it repels. And there's another force down here, but that's outside the problem, it's just additional information. How do we find the magnitude of that force? Magnitude of the force, pardon?
The same way.
Are you pointing to the previous screen or are you pointing to that screen?
I thought I had it, but I don't.
How do you find the magnitude of an electric force?
That formula from before?
Yes. I know the magnitude of the force. On 1 from 3 would be K Q1 Q2 over R squared. So 9 times 10 to the 9th times 5 times 10 to the negative 6 squared, because they're both the same, over that distance. And what is that distance?
I agree with you.
Oh, okay. I know that's 0.08 meters, and that's 0.08 meters. So it'd be 0.08 square root of 2. Whatever that is. 0.08 square root of 2 squared. 9 times 10 to the 9 times 25 times 10 to the negative 12 divided by 0.0128. That is about right. Louder, please.
17.6 Newtons.
17.6 newtons.
Yes.
I know in this particular case, that's a 45-degree angle there. So this would be in polar form, 17.6 newtons, 135 degrees. We're back to the first week of Physics 151. How do you add them?
Conversion from
You're almost there.
you have to convert it's in degrees, so you have to
For polar form?
it's the sine, cosine,
Okay.
yeah, you know what I'm saying.
I know what you're saying.
Do I know?
We need to get this into rectangular form. So we need to convert this. I have a vector here that has a magnitude of 17.6. I need to figure out what is to the left and what is up. That's a 45-degree angle. Let's see.
Bless you.
So this will be 17.6 cosine of 45 degrees and 17.6 sine of 45 degrees. It is going to require a little bit of thought here. There's a less thinking way of doing this. But we'll do it this way for now. So 21.1 I hat plus, well, I know that's going to be negative I hat.